Okay, everybody, we are going to work on Unit 1, Lesson 8 together, rotation patterns. This is my green book. All you have to do is follow along, take notes, and then I'm gonna insert some questions in Edpuzzles. Okay, so you're gonna need patty paper and something to write with. So I'm gonna rotate triangle ABC 90 degrees clockwise around B. So here's my patty paper, and I'm gonna trace it. I wanna start with my vertices, and I'm gonna lightly draw my shape in here. Follow along with me. All right, so the next thing I'm gonna do is I know that my center is B, so I'm going to make my cross at B with the arrow. Okay, so if I move it 90 degrees clockwise around B, it's going to face, oops, I need to make this longer so I can see it. Okay, so 90 degrees clockwise around point B. That means it needs to stay on B. I'm gonna put my pencil right here and I'm gonna turn it until the arrow points to the right. Okay, so it's gonna look like this. So I'm gonna press down on my tracing paper so it kind of puts an indent on my paper. Then I'm gonna go back in and copy it because I can see the indent right there, I think. It's gonna be about right there and right there. I know it covers up the words. I don't know why they did that in the book. Okay, rotate triangle ABC. So I'm gonna go back 180 degrees clockwise about point B. So this one is 90 degrees clockwise. The next one is 180 degrees clockwise about the same point. So now it's gonna face directly down. Okay, so I'm gonna go here, it's gonna go to the right, and I wanna keep my center in the same spot. I'm gonna keep going. Now it's gonna be directly facing downward. And I'm gonna press down just really good. I wanna get my vertices and then I'll connect them. Okay, I'm gonna make this one green. Okay, so here's my vertices and then I'm just gonna connect them. There we go. So this one is 180 degrees clockwise. Okay, all right, now I'm gonna rotate 270 degrees clockwise around B, so I'm gonna put it back on and put my pencil here and go 270. 90, 180, 270 to the left. I wanna darken my vertices so that I can see it, and I'm gonna darken this so it presses down. That way I can see it. And let's make it purple. All right, so this is 270 degrees clockwise. All right, my vertices are here and here. Okay, what would it look like when you rotate 4 triangles 90 degrees clockwise around B, 180 degrees and 270 degrees clockwise? What do you guys think? It kind of looks like a diamond or a square. Rotating it 90 degrees clockwise or counterclockwise interchanges the 4 copies of the triangle because it's the exact same triangle. Continuing the pattern of rotations, the next one would put ABC back into its original position. Those are some ideas that you guys might come up with. So in this case, this triangle is an isosceles right triangle. So that means when you rotate it, it fits directly next to each other. Okay, so let's go on to the next activity. So we're gonna go on to 8-2, and that is on the next page. Oh no, my marker went through. Okay. All right, so I want to rotate segment CD 180 degrees around point D. So I want to rotate segment CD 180 degrees about point D. Here's my patty paper. I'm gonna use the same patty paper that I had before, so that's on there, but it's okay. So I'm gonna trace my shape. This is C, this is D. Okay, so my center is here. My arrow's pointing up. Okay, if I want to rotate it 180 degrees, then my arrow needs to point down. Okay, so 180 degrees about point D. So if I rotate it 180 degrees, I want to put my pencil here. My arrow is going to point down, but it's going to line up with the original line. Okay, so if I just darken this a little bit so that I can see it. All right, and then I'm going to take it off, and I know where it is. So I'm going to take it off. It ended right here, and it was a straight line from here to there. What I do notice that this becomes C prime. Okay? So this is 180 degrees around point D. All right, now I want to do CD 180 degrees about point E. So CD, same line, so I'm going to put the line back, 180 degrees this time around point E. Okay, so point E is up here. So I need a new center. So this time my center is going to be, same line, my center is going to be up here, which means I need a new arrow. Okay, so now I'm going to do 180 degrees about point E, and I'm going to draw its image and label the image. Okay. All right, so rotate CD 180 degrees around point E and draw and label its image. Okay. All right, so this time it's gonna go up here. So it's gonna land here, and I can kind of see where it is. Let's make it purple. All right. Purple. Wait, I lost it. Let's do it again. Here. My fault. I'm just gonna darken that because I know it's there and there. Let's make it purple. Here and here. Yep. Okay, and it said, now this is 180 degrees about E. And that is 180 degrees about D. Okay, all right, now we need to rotate, so it wanted us to draw its image and label the image of C as A. So it wanted us to, C prime, it wanted us to call that A. So I'm just gonna put A there. And then when we did it again, they wanted us to label that something else. They wanted us to label that as, draw its image and label the image of C as B and the image of D as F. This is B and this is F. Okay, cool. All right, one more time. Rotate segment CD 180 degrees around its midpoint. Okay, so that's G. So now my center is going to be right here. So we have a different center. Same shape, different center. So G is my center now. So when I rotate it, I'm going to put my pencil right there. Oh, it's right on top of it. Okay, and so I'm just going to, what is the image of C? What is the image of C? It's actually at D. So here's my new shape. It's like the same exact line, except for this is C prime and it's already labeled D. Okay? All right, so let me just give you a little bit of information about what we just did. So I rotated it 180 degrees about the end point, and what happened? Well, the line doubled. So if I rotate it 180 degrees about its end point, the line doubles. If I rotate it 180 degrees about a point off of it, what do I get? I get a parallel line. So this line is parallel to my original line. So if I rotate 180 degrees about a point off of the line, I get a parallel line. And if I rotate it 180 degrees about a midpoint, which is G, I get the exact same line. So when I rotate it, let me just write this down in number 1. When I rotate it 180 degrees about point D, which is the end point, I get a line twice as long. When I rotate it about point E, which is off the line, I get this line here, which is parallel to my original line. And when I rotate it CD 180 degrees around its midpoint, so midpoint this time, I get the same line. It just fell right on top of itself. Okay, awesome. So those are I just rotate a segment 180 degrees about a point. I just told you the 3 different scenarios, and we answered those questions already on the previous page. All right, we're gonna skip the Are You Ready for More? And we're gonna go to 8.3, which is a pattern of 4 triangles. Okay, this one is kind of fun. Okay, so we are starting with triangle ABC, and that's this one here in the corner. You're gonna get a fresh piece of patty paper, and it says, describe a rigid transformation that takes ABC to CDE. So first I need to trace it so that I know what's happening. Okay, so just gonna lightly put the lines in between so they don't disrupt things for us here. Oops, that was messy. Okay, I am going to label it A, B, C. Okay, so the endpoints are the most important part. Okay, describe a rigid transformation that takes triangle ABC to triangle CDE. So basically I want it to go over there. I'm also going to label my right angles so that I keep track of where it is. I'm just going to label it with a pencil here. Okay, so there is my shape. Okay, I want it to go over there. So I'm going to need to get it over there somehow. Okay, what if I translated it so that B lined up with D? Okay, and then after that, I rotated it about a center. So starting here, translate it from B to C. I'm sorry, from B to D, so that B lines up with D. Then after that, I would rotate it 90 degrees counterclockwise, and then it lines up. Okay, so let's write that down. Translate from B to D, and then rotate 90 degrees counterclockwise about center D, which is right up there. So one more time, from here all the way to there, and then if I put my pencil right here and rotate it, it ends up there. Okay, that's the first one. Describe a rigid transformation that takes ABC to EFG. ABC to EFG. Okay, so I need to get it over there somehow. I need to get it over there. What are some ideas? I want you guys to brainstorm that right now. What are some ideas to get it from over there to all the way over there? Okay, what if I just slid it, did this kind of the same idea, slid it from B to F. If I slid it from B to F, and then obviously I would have to rotate it, okay? So that's an idea. Let's see, would a reflection work? If I reflected it, let's flip it. Now that I flip it, it's going the wrong way. So a reflection won't work. It has to be a translation. So slide it over here somewhere and then rotate it. So if I went from B to F, then I rotated about point F, that would work. So translate from B to F, and then once I got to F, how far did I have to rotate it? Let's see. I could go either way. Let's see, if I go this way, that's 90, that's 180. If I go this way, that's 90, that's 180. So translate 180 about point F. I'm sorry, rotate 180 degrees, and it doesn't matter the direction, about point F. Okay? All right, let's do 3. Describe a rigid transformation that takes triangle ABC to triangle GHA. ABC to GHA. So I'm going to put ABC back on there. Now I'm going to the last one. How could I get over there? I want you guys to think about that for just a second. Okay, what if I do the same pattern? What if I go from B down to H? If I go from B down to H, a translation, and then I would have to rotate it 90 degrees. 90 degrees counterclockwise. I could also rotate it to 70 degrees clockwise. You get to the same spot. So I'm actually going to write that down. Okay, one more time. Translate from B to H. Translate from B to H. Okay, and then after I translate from B to H, then I want to rotate it 270 degrees clockwise. Do segments AC, CE, EG, and GA all have the same length? Well, in class on Thursday, Friday, we talked about rigid transformations. And we know that rotations and translations are rigid transformations. If they're rigid transformations, that means that the corresponding side lengths are congruent. Great. Okay, hopefully you copied that down. Lesson 8 summary. All right, so this is kind of what we did at the beginning. How come it's not? Oh, there we go. When we apply a 180-degree rotation to a line segment, there are several possible outcomes. The segment maps itself onto itself if it's on the midpoint. It overlaps with the segment and lies on the same line. and that's it's the endpoint. And if it does not overlap, and then that means it's parallel. We can also build patterns by rotating a shape. For example, triangle ABC shown here, if we rotate it 60 degrees, 120, 180, 240, and 300, we can build a hexagon. So we just learned about patterns of rotations today. Bye guys. See you later.